Welcome to the Omar Alayli podcast, your go-to podcast for exploring the diverse field driving space exploration and technology. I'm your host, Omar Alayli, and today I'm thrilled to be joined by José Mariano López-Urdialess, the CEO and co-founder of Zero to Infinity, a space transportation company that is simplifying access to space through elevating its payload to the edge of space. Jose, thank you for joining us today and taking the time to be here.
My pleasure, Omar. Hi, everyone.
Okay, so for our listeners who might be new to the concept, how would you define near space and what are the key characteristics that distinguish it from low Earth orbit and outer space?
Yeah, so near space. What do we mean by near space? So the company is called Zero to Infinity, but we're not starting. We were starting from zero, but we're not yet at infinity. We're at an interesting middle ground between airspace, where airplanes fly, and orbital space, where
Mhm.
satellites spin around the Earth. So there's like a no man's land between where wings work and where you need to be really going seven kilometers per second. You need to be going really fast to fall over your own trajectory,
Mhm.
which is basically being in orbit. So that area is, sometimes some people call it stratosphere, some people call it high altitude, like high altitude ballooning, but those terms are not very helpful because a conventional Boeing or Airbus airliner is already flying in the stratosphere when it's
Mhm.
cruising over the oceans. So near space is a better term. Actually, I believe that's the Pentagon that's the one that's been introducing that, and everybody's kind of adopted it. So what happens there? You have a mixture of properties between being in the atmosphere and being in space. So balloons work. That's one of them.
Mhm.
Like balloons, if well designed, they can float just like they can float here at sea level. They can float also at near space. But the sky, for example, the sky is black all the
Mhm.
time, just like in orbit, like
Mhm.
just like when you are very far from an atmosphere or like on the moon. So in that sense, it's much more like visually near space looks almost exactly like space. So what do you see? You see the earth blue. You see a country like a piece of a map. You don't see,
Mhm.
it doesn't look like looking out the window on an airplane. It looks like you're in orbit. Of course, you're not as far as from orbit. In orbit, you might be at 400 kilometers. Here, you might be at 40 or 36 something, but it's still enough to see, let's say, the whole of Spain or the whole
Mhm.
of Italy. The shape, or your state if you're in the US. So you see a lot of area, and the blue of the sky that we're used to seeing here on the ground is below you
Mhm.
and at the horizon. So you see a little thin blue layer of the air, which is actually the light coming from the sun being scattered and making it look blue. And that phenomenon of scattering is happening below you, is happening underneath you. So you're above 99 or so percent
Mhm.
of the atmosphere. And a lot of people say, oh, but you're not in space or whatever. Well, that's a debate. Like, that's an endless debate because we are already in space. When you elevate yourself, when you go to the high ground, you can act on things differently. You can see things differently. And that's what we can do. What got me into near space is that it's being overlooked.
Mhm.
It's a low hanging fruit. Before, having mining on the asteroids or theme parks on the moon or cities on Mars and all these wonderful plans that everybody has. Hey, there's something to be done really quickly that requires a tiny fraction of the capital to do any of the above, and that can actually make be economically sustainable and improve the lives of people. So that's why I'm focusing on near space. But of course, at Zero to Infinity would like to go beyond, not just to
Mhm.
near space, but it just makes sense to not overlook that step.
So let's start with a bird's eye view and quickly look at your industry. What are some of the core technologies and types of end products that are currently being utilized or deployed in this near space environment by various players in the industry?
We can distinguish between, let's say, old space or traditional things that have been happening for decades with very
Hmm.
little innovation, and the new space, which are things like what we're proposing. So traditionally, every day there's about 3,000 little weather balloons that are flown into near space, and thanks to them we have very good weather forecast. Okay, so
Hmm.
that's something that people don't think usually, but it's something is the most used near space feature. Some people have been trying to, just like you can fly a little weather station with a bigger balloon, you can fly a telecommunication tower, like a
Okay.
5G or 4G tower. And
Hmm.
Google, for example, had a very, very big project. They invested, them and their Japanese co-investors, a
Hmm.
few $100 million to develop direct to device connectivity from near space. So your phone can get, you can send messages and look at your email, etc. In places where you wouldn't have the coverage.
Okay.
Another application is Earth observation. Okay,
Hmm.
from balloons up there, you can see fires happening and monitor them in real time really well.
Hmm.
And this is something that could benefit places like California, like Bolivia, Indonesia. So, of course, you need to look at the integrated response, not just
Hmm.
okay, we see the fire, we can do nothing about it. Of course, you need to work with the relevant stakeholders so that you can react. But having an early warning and a very early monitoring can reduce the impact of fires, for example. So and then up there, there are kind of four kinds of vehicles that fly in near
Hmm.
space. So let's start with the most popular one, the rocket. A rocket can go into near space, but then it falls back, and that's just like when you fly with Virgin Galactic or Blue Origin, or you have your traditional sounding rocket. It goes up and stays in near space for a handful of minutes, for a few minutes. But that's a very short time. What else you can fly? You can fly a balloon like we do. We fly a balloon, it stays up
Hmm.
there and it can last. There's balloons that have lasted over a year in near space.
Hmm.
But the issue with the balloon is that it drifts. High altitude balloon is typically a balloon filled up with gas
Hmm.
that is less dense than the air, like a lot less dense than the
Hmm.
air. So it floats and pulls the plastic and the of the envelope of the balloon and the payload with or the
Hmm.
gondola that hangs from the balloon up until it gets to a point where it's the average density of the whole system, the ensemble of things is more or less the same as the exterior density, and there it stops. So that's a high altitude balloon or near
Hmm.
space balloon. And then there's another kind of vehicles that can fly up there. Some people call them HAPs, like high altitude platforms, and these
Hmm.
would be either very very long airplanes with very
Hmm.
very high aspect ratio wings, and those can fly more or less at those altitude at the bottom of near space, just at the edge, around 20 kilometers. Or you can also fly a zeppelin, like an airship, and
Hmm.
make it fly up there. And there's a company in America called Sky, like SCEYE, that
Hmm.
has a beautiful like metallic finish airship that flies up
Okay.
there. And then there's Airbus that flies the Zephyr, which also flies into near space. And we, as Zero to Infinity, have been privileged to fly some of their payloads to
Okay.
them on our balloons. So we got some insight into the program. And these new kinds of systems for near space are so far only designed for let's say uncrewed missions or robotic missions.
Okay.
They carry very little payload. Like the Zephyr plane maybe carries like 3 kilograms or something like that. So of course you can take pictures, but you cannot do much more. And the only really heavy system to go into near space so far are either rockets that, yeah, they can lift tons, but they don't stay up there. They fall back very quickly. Or balloons that, hey, they can stay up there for a long time. And that's what we have.
Okay. Let's focus on zero to infinity.
Sure.
Um, you offer a range of services, including Elevate for payload transport,
Mhm.
Loon for human near space experiences,
Yeah,
and Blue Star for satellite launches. Let's delve into each of them, starting with Elevate.
sure.
How is the payload elevated? And what kind of payloads would you be typically lifting to those altitudes of 30 to 40 kilometers?
So the payload is uh, elevated by a balloon. When you fill up the balloon, it looks like empty here near the
Hmm.
ground. It looks like an empty plastic bag,
Hmm.
transparent, and then you release it, and it goes
Hmm.
up. And as it goes up, the helium, because we use helium gas inside the balloon, it starts expanding, expanding until it completely fills the envelope.
Hmm.
And these envelopes that we fly are open, so the pressure inside is the same pressure as outside. You
Hmm.
can't pop them. Like if you went there and tried to pop them, nothing would happen. Like they because it's zero. They're called zero pressure balloons,
Okay.
and then they can last a few days up there. Okay. There is a technology to last much longer, as I said earlier, that can last for a year, and those are they have a different shape. Like the ones we fly, they have a shape a bit like an onion, like upside
Hmm.
down like that, or a drop upside down. The ones that can stay much longer, they are closed. Their skin is thicker, and they do have a differential pressure. They have some extra pressure inside, and of course, then you could pop them theoretically. And
Okay.
those are called super pressure balloons. Those are the kinds that Google was working on for the long-term telecommunications system, Loon.
Hmm.
And
What kind of payloads would you be typically lifting? How much mass?
heaviest payloads that had been taken up there to near space was historically was 18 tons. Okay, so there are balloons that can take 6 tons, 8 tons, those kinds of weights. For most of the missions that we're looking at, we just need maybe a few dozens of
Hmm.
kilograms. Sorry,
Hmm.
so 15 kilograms or 60 or 100 kilograms. Most missions that's more than enough, because you can do a lot with electronics with 15
Hmm.
kilograms. You could with that you can fly cameras, you can fly even radar, do synthetic aperture radar from high altitude. um, yeah, you can do many things. Another very interesting test that you sometimes do, like America has done those very well, is let's say that you want to land on Mars,
Hmm.
and so you design your parachute system and everything, and your descent system to fall through the very thin atmosphere of Mars.
Hmm.
And how do you test that? Well, you cannot go to Mars to test it because you only get one shot there. But we are very lucky as humans that we have something very similar to the atmosphere of Mars in near space. Like some layers of near space, their density and their like properties, viscosity, etc., the properties of the air up there is very similar to the properties of the air on Mars. And then if you just drop it from high altitude from in near space, you can reproduce the opening of the parachutes, and that's something that can be also beneficial. Of course,
Okay.
it's just a test, but and yeah, you and again the other thing you can take, as I said earlier, like Google was trying to do, is antennas like radio extenders or 5G,
Hmm.
either for data, for voice, or for first responders in case of a mess. There's a problem on the ground. This was done in, let's say, for example, in Puerto Rico. They had some problems some years ago, and they were using near space balloons to provide basic connectivity services to the people in Puerto Rico.
Okay. Cool. So let's move on to Bloom, the concept of Bloom, which is offering a unique perspective of Earth from a comfortable setting, is fascinating from a tourism, entertainment, and educational standpoint. Could you paint a picture for our listeners of what that experience is like and what kind of structures will carry the passengers?
So yeah, imagine you come over here to southern Spain, you eat well, you spend a couple of days with us. We want to make sure that there's no jet lag, there is no hangover of any kind. We want you to be at your prime, calm, well rested, and then just before dawn, you get into the capsule. You hear the sound of the inflation of the balloon, the helium going through the inflation tubes, and the balloon rises, and the moon shines on it, and you go, and the impression is that it's the Earth that is leaving you, because
Hmm.
you don't feel that you're moving. because you're moving vertically, and but you're also drifting with the wind. So it's like everything goes away, and
Mm-hmm.
there's no noise because there's no engine or no burner like in the traditional hot air balloons. It's just silent and calm. And then the as you go up, 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 the horizon starts bending like this,
Mm-hmm.
and more stars become visible, even more than you already had at the beginning. And then you see Africa and the Mediterranean, the Atlantic, tall mountains, desert areas, forests, and then you see dawn.
Wow.
You see the sun coming out from the horizon. But this is a new kind of dawn because you see the sun coming up, but the sky doesn't is not illuminated. It's still
Mm-hmm.
black. You see dawn like the astronauts see it. They
Okay.
see it 16 times a day. You only see it once in a bloom flight. But then when you're up there, then there's two pilots. They explain things to you. They are kind of mediating with the experience. They can serve you tea or whatever you want to do. The most interesting part is the part that I'm not going to describe, that anybody can imagine in their own imagination. Maybe they want to do Chinese painting, or write a poem, or get married, or renew their vows. Part of what makes this exciting is to provide an opportunity for those human expressions to flourish there in space. And then after several hours up there, you initiate the descent, and the descent
Okay.
doesn't happen with the balloon attached. Okay, the balloon separates, and the whole capsule comes back down with a very large parafoil, which
Okay.
has already been tested. Again, all the technologies that I'm describing that we do are commercial off the shelf.
Mm-hmm.
You can assemble them together, they exist.
Mm-hmm.
The TRL is as high as you want to call it, or the
Okay.
technology readiness level. So yeah, then just before touching down, there are big airbags that pop up at the bottom of the capsule so that the hull doesn't impact the ground. And because the parafoil is guided, the pilots on board can select to land on the area that is safest and more comfortable. And we do all this over land. Okay.
Okay.
And the startup port already exists. It's built. It's in Jaén in the south of Spain, and it's just the right distance from the sea so that you don't have splash landings. Splash landings are doable, but they're expensive and uncomfortable and messy.
So let me follow up on the capsule. When you're designing the capsule, does it have to be certified as a human rated, same as it's as if you're designing for low Earth orbit? Because you are still designing for atmospheric differentials. You will need life support systems, shielding, thermal insulation, power, right?
Yes, you need. It's so the beauty of flying on a balloon is that the laws and certifications and rules for balloons predate aircraft. Like,
Mm-hmm.
they come from the 18th century.
Mm-hmm.
So it's the total is the opposite problem that, let's say, the all these vertical takeoff and landing multi-copter contraptions that are trying to find how to fit on the regulatory framework, because they are
Mm-hmm.
a new thing. They're not a helicopter, they're not a drone, they're what are they? So we are a balloon. And it's wonderful that the rules are clear. We know what we need to comply on. To be honest, we are a balloon for most of the flight, and for the end of the flight, we are a glider with the special conditions because we're gliding.
Okay.
But in
Mm-hmm.
both cases, gliders and balloons have existed from a long time and are very well understood. The requirements that are asked by both the FAA and EASA are relatively mild and easy to meet
Mm-hmm.
because of these things. Of course, we put a lot more extra effort because we are the last ones that want to have any kind of issue. For
Mm-hmm.
example, we will be using pressure suits for the test flights. But if you remember, Blue Origin, when they did the first human flight with Jeff Bezos and his brother, they were not wearing pressure suit. Nobody asked them for.
Mm-hmm.
The same is true for Virgin Galactic. They were wearing oxygen masks, but not pressure suits. So, but we will be using pressure suits. Why?
Mm-hmm.
It's more expensive, and yeah, but we care about safety like a
Mm-hmm.
lot.
Mm-hmm.
And because this is a commercial concern, like, we have investors, we're not big media spender. I'm not Amazon, so we can't afford as a company to have
Mm-hmm.
any issues. So we are extremely focused on safety, and
Mm-hmm.
that's fine. So So the regulations are there and for good reason, but they are relatively easier to meet because we're not a new category. Of course, we fly higher, but that doesn't make it a new category.
Okay, great. Let's move on to Blue Star.
Sure.
Blue Star aims to revolutionize satellite launches by using Near Space as a launching platform, right? What are the key advantages of this approach compared to traditional systems?
Yeah, most people think that the advantage is that you save propellant because you're already farther. That could be farther from the truth. The thing is, when you have a very hard problem, breaking it into two parts usually is good because then you can use one tool for one part, another tool for the other part. And that is exactly what we're doing. Reaching orbit is basically two hard problems. One is getting out of the soup of air that doesn't let you pick up speed easily,
Hmm.
and then picking up speed where it becomes easy.
Hmm.
Like going fast, going very fast in the atmosphere is very hard for two reasons. One, drag, okay? But also the rocket engine itself, what does a rocket engine do? They transform chemical energy
To kinetic.
into kinetic energy. And
Hmm.
that transformation has an efficiency.
Hmm.
And the efficiency is very high if outside there is vacuum or something like vacuum. But if
Hmm.
outside, again, there's a thick soup of air, the efficiency is terrible and it becomes incredibly expensive to make it efficient. And then you need high pressure turbo pumps and all those things, and hundreds of engineers and lots of test benches and things like that. You don't need that if you're igniting your rocket engine at high altitude. The thing is, at high altitude, rocket engines are in their natural environment. They like it. They pick up speed very well. They turn that energy in the propellants into
Hmm.
kinetic energy in a much more efficient way. You can also have like bigger bells, and also then there's second order benefits. Like it's easier to control because you don't
Hmm.
have a bunch of regimes. Like when you're launching from the ground, you have zero speed, you have subsonic, transonic, supersonic, hypersonic, and vacuum.
Hmm.
And every regime is a bunch of tests on the computer, on wind tunnels, a bunch of engineers, a bunch of headaches. If you just say, okay, all that's done by the balloon, and then I have vacuum,
Hmm.
a lot easier. So there are many advantages in terms of reducing the size of your team, reducing the complexity of the technical challenges that you have, and also there are other benefits that are from the perspective of the payload. Like if you are the little satellite sitting there, how is it different to fly on Blue Star or to fly on, let's say, Rocket Lab Electron? Well, on Rocket Lab
Okay.
Electron, you need to fit on the little tiny tip of the rocket. And okay, we're used to seeing satellites, with the solar panels and their antennas all bent, but Blue Star has more like this shape.
Hmm.
So the fairing is almost 4 meters wide. So
Okay.
you have a fairing like a heavy launcher or a medium-sized launcher, but you're carrying a light payload. So then you can have bigger things, and
Hmm.
also the vibrational environment is very different. If you're flying as a missile, from the moment you ignite the missile, there's a shockwave that goes down, comes back up from the ground, and
Hmm.
shakes everything a lot. And then when you're going through transonic and max Q, you got all sorts of shaking, and then when you separate the stages, it's all full of torture, and that's why satellites need to be put on those tables where they shake them and they do all sorts
Hmm.
of things to them. Well, imagine the ride on Blue Star is gentle. The ride on the balloon, of course, is very gentle, and then the ride with the rocket, it's like an upper stage. It's like a
Okay.
last stage, so you don't have all those highly violent phases of the flight, and that allows you to fly very delicate things.
Hmm. What kind of orbits are you targeting?
Low Earth orbit,
Low
yeah,
Earth orbit.
yes, we're not
Okay.
looking beyond. There is a sweet spot for which Rockoons or rockets being launched from balloons make sense in
Hmm.
the order of a couple of hundred kilograms maximum. Going further beyond that, the balloon doesn't help you that much.
Hmm.
Let's put it that way. So the smallest the payload you're flying, the more the balloon helps you. But there, of course, there's a minimum size of payload around, let's say, 30, 40 kilograms that where it really doesn't make any economic sense to develop a
Hmm.
launcher. So there's like, yeah, like between 30 and 200 or something in polar, at around 600 kilometers altitude. That's the range where this concept has merit.
Okay.
Outside of that, it really doesn't.
So what's your niche market?
For Blue Star, the responsive launch mostly for intelligence, either image or SIGINT. There's a
Okay.
crisis. We need to put a satellite really quickly in this orbit, and we can't wait. We don't want to talk to anybody about it. And yeah, there's some stealthy and some security sides of it as well. And we believe that there's a market for those.
Okay. So, what is the current status of these services? Could you share what significant tests have you conducted and what upcoming major milestones are you looking forward to?
So Elevate has been fully operational. I mean, we've done many missions for different customers. Of course, we can always improve things, but it's an existing capability. Bloom, we've flown 3 pressurized capsules. The largest one that we've flown is a 44% scale of
Hmm.
the one that will carry 4 passengers and 2 pilots. It's currently sitting in a museum in Zaragoza, Spain. You can visit it in the mobility museum there, hanging from the ceiling. It's the same vehicle that we flew. And now we are completing a 2-seater that is going to be doing a series of flights to 8 kilometers, 10 kilometers, 20 kilometers, etc. And it's under construction. So the 6-seater, we haven't started bending metal, like, or it's still just on the drawing board. I mean, it's designed and the subsystems are selected, but we haven't moved on because mostly lack of funding. Okay. Um, and then for Blue Star, which is a project that would require a lot more funding than taking humans, surprisingly. I mean, Blue Star is about 3 times more capital intensive than Bloom. We have flown a little rocket from a balloon. Okay. There's a government program a long time ago that did it, but not as a private company.
Hmm.
And we've also tested the igniter of the rocket. We've done some manufacturing tests of 3D printing some of the rocket engines with our friends from Fadacatech in Seville. But to be honest, the development of Blue Star is also on hold because of lack of funding. I mean, we were very happy to be pre-selected by ESA, the European Space Agency, as a potential micro launcher concept, but then
Hmm.
we didn't manage to get any of the national delegations to foot the bill for the continued development. So that's why it's still a little bit on hold. It's quite fascinating to see that we were probably the first micro launcher to be proposed in Europe, commercially as a private company back in
Hmm.
2018. But now there's like 20, and there's like 3 or 4 in France, 2 in Spain, 3 in Germany, everywhere, and they're all of them the same. They're all the same architecture. Is an Scud missile with an upper stage.
Okay.
It's a very well known and understood architecture that has been done in the past and mass produced in some cases for defense applications. And I don't know. I would expect to see more innovation. Like, you may like or not like Blue Star, but at least if it fails differently.
Hmm.
Okay, it pushes the envelope. It does things in a different way. It has different economics, different physics.
Let's move to challenges and opportunities. As with any pioneering field, near space exploration undoubtedly faces its share of challenges. What are some of the most significant technical hurdles you are encountering?
Technical hurdles. That we're very very careful to choose technologies that are very well proven,
Hmm.
but because we have very limited budgets and we need to get results. Okay. So for example, it would be really cool to have reusable balloons. Okay. Our balloons are single use every time.
Hmm.
It's a technical challenge to make it reusable. I'm sure it can be done. Basically, a balloon envelope is a reinforced plastic bag, but
Hmm.
we learned how to reuse plastic bags, like or parachutes. So shouldn't be that complicated. But we try very hard not to go there. We just say, okay, once we make money, we'll work on those technical challenges. For the
Okay.
moment, let's just use what works. So then the challenges come from things like repeatability. For example, if we have this limited funding and we can only do 5 tests, so maybe 5 is not enough statistically to get certain results. To get so because of the fact of the low cadence of flight, that introduces some problems. I can't overemphasize how important that is. And that way you get a much better understanding of the statistical behavior of the system. Things like keeping people alive, having the windows not get full of frost, we know how to do that. Like, it's been known for a long time. Um, and then there are cool improvements, that we have for the down the road. Blue Star initially won't be reusable, but I believe that especially the first stage will have very very little thermal punishment on the
Okay.
way down, because it's a three-stage launcher, so the speed is divided between the three stages, and the first one gets a little bit less than a third. So it slows down, not that high up and not that fast. And also its shape is like a donut. It's very very advantageous for the dynamics with the shock wave, etc. So it's not gonna get like a blowtorch anywhere. That's going to be super fun to and learn how to do reusability on an easier problem than what Blue Origin or SpaceX have been doing.
So, what about regulations? What are the key regulatory issues that need to be addressed to foster the growth of this industry in a safe and responsible manner?
I think reuse regulation has been mostly an excuse for lack of performance in fundraising. Like, if you can't fundraise, you can always say that it's because the regulations, whatever. Like, I
Hmm.
know the regulators, they're bored of waiting. They want to see things fly. They are not the bad guys that we tend to show. And the problem is that if you only fly every few years or something like that, then the people change, and then you need to convince new people, and they want to be safe. But again, the key is cadence. If you're flying and you develop a relationship with the regulators, with the insurers, with the air traffic controllers, everything flows. Like, everybody wants to see more spaceships and more tourism and more applications benefiting citizens. Like, that's not the problem. Especially, I think there's an exaggeration about Europe being too regulating. As I said, I've been to Cologne. I've sat down with the EASA. These people want to see us succeed. They want to see these things fly. They want to make it easy. But if you can't pay your engineers to do the tests, then you never send them the data.
Yeah.
Things don't move. That is the limit. It's much more of a funding. I have to say that some people have been very very successful at funding, but as I said, the intersection between funding and real competence, not that large.
Okay. So, what about ethical considerations? What ethical considerations must be addressed, particularly when it comes to human safety, militarization of space, and environmental impact?
Yeah, that's a great one. Let's start with environmental impact.
Hmm.
I just seeing the magnificency of your planet, how beautiful it is, but then seeing a black column of dark smoke that you just left behind on your ride, that's going to generate some cognitive dissonance. That's not fun. We have zero environmental impact. Okay, it's
Hmm.
helium gas. It's a noble gas. It doesn't affect anything. It can't react chemically with anything.
Hmm.
And um, and most of the helium gas that is extracted from the crust of the earth is just vented. Okay,
Okay.
so people say, oh, but you're wasting the helium gas. Okay, have a conversation with all the mining companies or the oil and gas companies that are just vented to the earth. Why do
Hmm.
they vent it to the earth? Because the spot price, the price of helium, is too low right now for them to bottle it. I would love for more people to extract helium so that there is more, and it's cheaper. For me, that's better. But yeah. Um, so the militarization of space. I mean, we have to be very, I think, honest with this. Like, The whole space industry that we have is a side product of the fact that there's been military uses of it, like, and which is also true for computers and medicine and most of the stuff that we currently use. So yeah, I I think space is useful for three things: to go and see with your own eyes that you come from a planet, to connect, and to see. And seeing better can prevent misunderstandings and conflicts. And being able to see and learn and understand, it's a prerequisite from to avoid disaster. Like, so I think space and intelligence from space can help a lot prevent crisis, and I think space can certainly make us safer. But yeah, there's some scenarios in which it gets it gets out of control, like the Kessler syndrome or things like that,
Yeah.
when you have satellites hitting each other, and then there's a so we need to be responsible, because space could be one of those cases of tragedy of the commons, where everybody ends up putting things and attacking each other, and then it becomes useless for everybody. But fortunately, it's very large. I mean, there's a lot of space in space.
Yeah. So beyond the breathtaking views, near space could offer a unique environment for scientific research. Could you share some compelling examples of how this environment has the potential to enable advancements in fields like biomedical experiments or device testing?
Well, I'm going to start with astronomy. Just like it makes sense to put a telescope far away above the air, like the Hubble or the James Webb. Well, guess what? Putting a telescope up in near space, if the sky is already black, you're getting most of the benefits at a tiny,
Mhm.
tiny fraction of the cost. So imagine, for example, flying on the South Pole, let's say launching from McMurdo Station, a gigantic telescope that flies into the night, into the Antarctic night, and has a very, very stable temperature, because it doesn't go through cycles of day and night. It's all night, because it's flying, while it's night in the South Pole, and it's very cold and
Mhm.
very big, and it's just spinning around in the polar vortex, because the winds at high altitude in near space, they just spin around the pole. So that telescope would probably be very competitive in terms of scientific quality, compared to telescopes, let's say on low Earth orbit, and it would cost a tiny fraction of what they cost. So we can also learn how to live there. Like I think it's going to happen that just like there's a base in Antarctica on the ground, there will be a base in Antarctica at 30 kilometers altitude that will be spinning
Okay.
around. And why does that make sense? Well, like, what's the point? Well, it's learning how to live on something that is like the moon. So you have very, very long periods of sun and very long periods of lack of sun. So and outside it's vacuum. So if you are on a little laboratory spinning around on the South Pole, you have gravity, you have very long periods of night and day. So the conditions are extremely similar to those on the moon. And there's all these fashionable Mars analogs or moon analogs. So this is the ultimate one. Like, there you're doing it, and if you walk outside, you die just like you would die on the moon. And the thermal systems that need to work there and regulate things work like on the moon, because there is some
Mhm.
gravity, but it's mostly radiation dominated. It's not convection dominated. So that's a way to learn how to live in space or in planets or moons, that I would love to do at some point. With, of course, that is not a business in itself. That is something that is for research and for understanding. But hey, maybe some government wants to be the first one to have a Arctic or a polar, an edge of space station.
Okay. In the grand scheme of human space exploration, do you see near space primarily as a gateway to further missions such as orbital or deep space missions? Or do you believe it will become a significant destination in its own right, offering unique and valuable experiences, just like you were saying now, and opportunities?
I I think it's going to be the catalyst for much larger expansion into all the other things, because right now, who's interested in moon missions, or setting boots on Deimos or on Titan or whatever. These are nerdy people. Okay, most people can care less.
Mhm.
The moment that most highly influential people have seen with their own eyes what we've been talking about all this time, like, oh, the Earth is a planet, it's blue, sky is black during the day, all those things are connected. That completely is going to transform the space economy and the possibilities. And as we will move from helium, which is expensive, to hydrogen that is flammable, so we're not in a rush to move, but eventually will happen. Eventually there will be hydrogen, all sorts of vehicles using hydrogen, right?
Mhm.
So balloons won't be an exception. So when we move towards that, and maybe mass manufacture the balloons so they're very cheap and reusable, and suddenly the middle class can afford to have a ride like that, and maybe they even do it in several parts of the world. That's gonna be an adoption pipeline, if you will. So, but I think the most interesting effect is this change of, oh wow, this is not just for the nerds or the Elon Musks of the world. This is for everybody. That's what's gonna bring.
Okay, cool. Um, Looking ahead over the next 20 years, what emerging trends in the broader commercial space sector are you most excited about?
I want my phone to work everywhere.
Okay.
My kid's phone. Like, I'm excited about that. I follow the direct to device and all this. There's, as an engineer, I can't help to see, to separate the wheat from the chaff, because there's a lot of also hyping. You're not going to be able to be watching episodes of Game of Thrones or whatever you're watching in the desert for a long time. But yeah, I want coverage everywhere. I'm also very interested in better mineral exploration of the planet.
Mhm.
Like, we don't know what's underneath. Like, we're just learning that there's hydrogen, gigantic volumes of hydrogen under the crust that we could mine. And space, and near space in particular, can play a role in mineral exploration. I find that very, very interesting. There's been all sorts of spurious incentives in the whole mineral and oil and gas game, and space can reveal, can show, can let us see better what is there, what is economically advantageous to drill or not, or to extract. So I think that that's also something that it's going to be very interesting.
What advice would you give to the young generation of students or professionals who are curious about studying or pursuing a career in space?
I would advise them to dare, to write to people, to reach out, because there's a lot of the very competent people that are good at math or creative thinking. I think reaching out and asking, they'll be surprised of the response. Also, to study the human condition also. Okay, because it doesn't matter that you can have your dream, you can have your calculations, you can have your idea, but if you can't persuade others to join you in the dream and provide the resources, the funding, the team, the, the paperwork, then it doesn't happen. And myself, I tend to forget about it sometimes. So I think it's something that we should remind ourselves very much.
So, what's your favorite sci-fi book?
So I like sci-fi a lot. And but if I had to recommend one and point out one that I find it particularly fascinating, is Last and First Men by Olaf Stapledon. And that's it's really cool. It's about like how humanity would evolve, but in a very large scale, like millions of years and millions of years. So I also like very much the three body problem. Okay, that's,
Okay, yeah.
everybody likes that, right? Also the fourth one, the fun fiction that was written. That was also good.
Okay, so before we wrap up, is there anything else you'd like to share with our audience? Any announcements, or maybe for those who are now intrigued and want to learn more about Zero to Infinity and the exciting work you're doing, where can they find more information?
Yeah, they can find me on LinkedIn. They can find the company as well on LinkedIn, on X. Yeah, I'll be happy to answer questions and from the viewers directly. And maybe they know somebody that wants to contribute in some way, or they have a subsystem that we could use, or they know an investor that may want to fly in or get involved in this. So we're open to all sorts of conversations. Yeah, but the LinkedIn and X are the best ways to reach us.
Jose, it's been a great having you here. I really enjoyed our conversation.
Yeah, likewise.
To everyone else listening, this is the Omar Alayli podcast. Thanks for joining us and keep exploring.